Hi, I'm Andrea and welcome to Productive C Sharp. In this video, I want to code with you an algorithm to calculate the largest unique number in an array of numbers. For example, in this first instance, I have 9, that is the highest number. However, 9 is duplicate, so in this case I should not consider it. 8 is the single element, the single number that is the largest, so in this case 8 is the solution of the problem. However, if there are only duplicate numbers, there is no unique numbers, I want to return -1, okay? I'm just inventing things. I could say throw an exception or anything like that. How do you code something like this? This is a very common problem, and I want to write this with you to show you how dictionaries can really help to solve problems like this. The immediate reaction would be, maybe I should just sort the numbers, right? And then iterate through the array, going from the highest to the lowest number, and stop until I find my solution. That's certainly an option, but you know that sorting algorithms is semi-logarithmic, and there are faster solutions that can use a little bit of memory to build a temporary data structure, in this case a dictionary, to count the occurrences, and then use that data structure to really help in figuring out the solution. And that's what I want to show you, because these are very common things that you often need to do when you need to solve a problem. You have an initial input, you build temporary data structures to support you, and then you write an algorithm that is more efficient thanks to the data structure that you've just created. So let's instantiate a dictionary that I'm going to call count. And what I want to do is basically I want to iterate through the array and count the occurrences of every number. In this way, I will be very easily able to figure it out which numbers are unique, because in that case, they would have an occurrence of 1. Okay, so let's do a for each for number n in numbers, and if count contains key n, so if count already have the key, I just want to increment. Otherwise, I want to create the entry and it would be just 1 as occurrences. As you can see here, I guess some support to say you can do this a little bit differently. You can use the triad method. I quite like it when I do something like this, because it allows me to say, okay, try to add an entry to the dictionary with value 1 and key n. If that's fine, this will return true, and that's it. But if there is already an entry in the dictionary, this will return false, and then in this case I will just increase the count. So I think it's a little bit more compact, and I kind of prefer that than using contains key. I'm going to remove the parentheses because I don't necessarily like to use them and to make the code more compact when I don't need them. Okay, now I have a data structure, count, that contains the occurrences of every number. What I need to do now is do another loop through the numbers and only look at the numbers that have occurrences of 1 and trying to keep the maximum as I go through the list of numbers. So I'm going to create first the result that I'm going to assign to -1, and I want to return at the end of this a result. And I'm going to kind of set the result to the maximum unique number I found up to this point. So let's do another for each. When I loop through a dictionary, I like to decompose that into key and value using tuples. That is actually very nice in C#. So now I'm saying, okay, for every key value pair in the dictionary of count, if the value equals 1, that means there is only one occurrence, and the key, that is the number, is greater than the currently found result, what happened? It means I found a new result. I found a number that is higher than the previously found one, so I'm going to assign k to the result. and then I will return the result. Let's see if this actually works. I'm going to get a 8, that is the correct solution, and -1 for the second instance. So this actually works. So these are very simple algorithms, but it demonstrates something very important. You can actually create a temporary data structure, in this case a dictionary, a hash table, to actually simplify the algorithms in a later stage. Obviously, this requires a little bit of memory, because it requires an entry in the dictionary for every unique number. Okay, so this could be bigger. If the numbers of unique numbers is low, it's not too big, but it could take some space, of course. But you are trading off the space for speed, because adding elements and finding elements in a dictionary is OD1, is a constant operation. That means the creation of this dictionary structure is basically a linear in complexity. And then after that, I can just simply do a loop and calculate the result very easily, because now I have the occurrences data structure that I created that can simplify excuse me, solving the problem. So at the end of the day, this algorithm is effectively linear. And in a linear way, you can figure it out what's the largest unique number using a little bit of memory in order to build this temporary dictionary. If you use the solution of sorting the numbers and then trying to loop through that, that's also valid. But obviously, it's less efficient in terms of time, but it's more efficient in terms of memory. There is never the right way of solving a problem, but if time is what you want to optimize, this is the best solution. And it demonstrates a very important things that is very useful when you do coding interviews. You can decompose the problem into smaller problems and solve them, or think about, okay, is there some data structure that I can use that can be of support to make solving the problem easier? The biggest problem in this problem was effectively to identify the unique numbers, and the data structure really helps to do that very easily. As soon as you know which are the unique numbers, then it's very easy to figure out what's the maximum. Okay, so that's basically it. Thank you very much for watching.